Most people first meet creatine on a gym shelf. That history can make the brain story easy to miss. The more useful question is quieter. On days when your mind feels underpowered, could creatine help the brain keep its energy systems steadier? This matters because the brain is expensive to run. It is only a small part of body weight, but it uses roughly 1/5 of the body's energy. Thinking, remembering, paying attention, and controlling impulses all have an energy cost. So, this is not a story about getting wired. Creatine is not caffeine. It does not create a quick buzz. The better way to understand it is as part of the brain's short-term energy buffering system. Inside cells, the immediate energy currency is ATP. You can think of ATP as a tiny spendable coin. Whenever a brain cell fires signals, reset its electrical balance, or supports a connection with another cell, ATP is being spent. Creatine helps because some of it becomes phosphocreatine. Phosphocreatine can donate a phosphate group quickly, helping rebuild ATP when demand rises. It is not the whole energy system, it is a fast local reserve. That speed matters because brain cells do not have large energy stores waiting around. Their work happens in tiny local zones near synapses, ion pumps, and other busy areas where energy is needed at the right moment. Supplemental creatine still has to travel. It is absorbed through the gut, moves through blood, and is taken up by tissues using transport systems. Brain creatine does not rise like a switch being flipped. It builds gradually. That is why the brain health question is different from the usual quick-fix supplement promise. The useful idea is not a rush. It is whether better stores may make the brain more resilient when demand goes up. The evidence does not give one giant yes for every person in every situation. It is more like a map. Some areas are more promising, some are still developing, and some claims move faster than the research. Across trials and reviews, the most interesting pattern is not permanent genius or instant focus. It is modest cognitive support, especially in memory, reasoning, processing speed, or attention when the brain is under strain. Sleep loss is one of the clearest examples. In sleep restriction studies, creatine has been linked with better performance on some demanding tasks. The explanation is plausible. When sleep loss stresses brain energy, a faster reserve system may matter more. Memory is another area where reviews have found signals of benefit, but the size of the effect is not dramatic, and study designs differ. The careful reading is, there is a signal, not a guarantee. This is where caution helps. Some scientific and regulatory reviews remain wary of broad claims that creatine improves cognition for everyone. That does not erase the findings. It keeps the claim in the right-sized box. So the strongest question is not, does creatine make every brain sharper? A better question is, when might an energy buffer become useful? That points us towards pressure, lower baseline stores, and life stages where energy demand is higher. Start with sleep deprivation. Poor sleep does not just make a person feel tired, it changes the conditions the brain is working under. Attention becomes harder. Reaction time slows. Working memory becomes less reliable. That is why new parents, shift workers, students, and travel-weary workers are such relatable examples. The point is not that creatine replaces sleep. It is that research is most interesting when sleep is already being squeezed. Mental fatigue works in a similar direction. Long meetings, complex decisions, detailed analysis, and constant task switching all spend cognitive resources. Creatine's possible role is not motivation. It is energy buffering during sustained demand. This makes the common afternoon crash easier to understand. Sometimes the problem is not a lack of willpower. The brain is trying to keep high-level work going while energy systems, sleep pressure, and stress are all competing. But pressure is not permission to overclaim. Creatine is not a substitute for sleep, food, workload management, mental health care, or medical support. It is one small piece in the energy picture. The second big idea is baseline. People do not all start with the same creatine stores. Diet, age, sex, body size, health status, and lifestyle can all change the starting point. Vegetarians and vegans are a clear example because plant foods contain little to no creatine. If baseline stores are lower, a supplement has more room to change the system. That may explain stronger responses in some plant-based groups. Women are another group where the discussion needs care. Some research suggests differences in creatine synthesis and life stage demands. Menstrual cycle patterns, pregnancy, menopause, sleep disruption, and stress may all change the energy context. That does not mean every woman will feel a cognitive difference. It means the average physiology and the lived context may make this area worth studying more seriously than old gym-centered creatine messaging allowed. Older adults may also be more relevant than the average healthy young person. Aging can bring changes in cellular energy metabolism, processing speed, memory, and independence. Creatine research in aging is broader than cognition alone, but brain energy is part of the reason it matters. High-stress lifestyles form the fourth group. Chronic pressure, poor sleep, and heavy cognitive load can raise demand. If creatine helps most when the system is strained, these contexts become more important than a normal low-pressure day. The useful takeaway is not a ranking of who deserves creatine. It is a response map. Lower stores and higher demand may make benefits easier to detect, while well-rested people with higher baseline intake may notice less. The practical part is less dramatic than the marketing. The best studied form is creatine monohydrate. Alternative forms often cost more, but the cognitive evidence does not clearly show that they beat monohydrate in healthy adults. Common research and everyday protocols often sit around 3 to 5 grams daily. Loading phases are more associated with speed of saturation and sports use. For brain health framing, consistency is usually the more relevant idea. Timing is similar. Taking creatine with a meal may support uptake and makes the routine easier, but the brain story is about stores building over time. It is not about chasing a perfect pre-task minute. Safety is also part of the map. In healthy adults using recommended doses, creatine has a strong safety record. Blood creatinine can rise because creatine turnover rises, so that marker needs context rather than panic. Some people notice temporary water changes or digestive discomfort, especially if doses are high. Those effects are different from kidney damage. Still, the safest framing is boring and useful. Dose, context, and individual health status matter. Anyone with kidney disease, complex medication use, or uncertain health status should speak with a GP or qualified clinician before adding it. That is not because creatine is automatically dangerous. It is because personal context changes the decision. Expectation matters too. The evidence points towards support under certain conditions, not a personality change, not instant motivation, and not a treatment for cognitive decline. The less glamorous claim is also the more honest one. So the best way to think about creatine for brain health is this: backup, not buzz. It may matter most when the brain is tired, stressed, older, underfed for creatine, or being asked to keep going without ideal conditions. That makes this a different creatine story from muscle power or gym performance. The brain question is slower, subtler, and more conditional. It asks where energy support might change the experience of pressure, not whether a supplement can make everyone sharper. For the full article and supporting references, use the link in the description. The useful answer is not hype. It is a clearer map of when creatine might help the brain and where the evidence still needs care.